Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 1.3, Lesson 3 on Thermodynamics. A kind of problem that you might get, the second type in this series, and this includes finding thermal conductivity. Also, the letter is K for that. The other one that we found was for the final temperature, involving using the equation Q equals M times C times delta T. But now we're going to use a different kind. So first of all, let's first read the word problem we have right here. So a 1/6 inch thick glass box with dimensions of 11 inch by 11 inch is covered with an unknown 0.93 inch of insulation material. Determine the thermal conductivity K for the insulating material if a 78-watt bulb is used to heat the box. The bulb maintains an inside temperature of 20 degrees Celsius higher than the outside temperature. First of all, in a problem like this, you need to make sure that you note this, that it has to be in meters. For length, it has to be in meters. I'll just write it out. It needs to be in meters. If it's not, then your answer will be incorrect. So meters, that's what it needs to be in. We'll have to convert that later on because notice it was given in inches. So a visual that's terrible, unfortunately, because I'm not good at drawing online, but so there's a glass box and it's being covered with this pink insulating material. I mean, it doesn't matter that it's pink, it could be any color. And inside the glass box there's this bulb that we have information of the material type, and it is a 78-watt bulb. Now the first thing we need to do is, so we're trying to find thermal conductivity, which is K. What's the equation for that? Well, I gave you that in lesson 1. It's on your formula sheet, and it is P times L divided by A times delta T. Remember, delta is a part of it, it's not multiplied by the T, it's all together in one thing, and it's uppercase T. So now let's write each of these components. We obviously don't know what K is because that's what we're trying to find. We can see if we can find out what P is, what L is, what A is, and then what delta T is. So first, what's P? Well, P is power, and that is simple. We already know what that is. That is going to be 78 watts. That's right off the bat. We already know what that is. That's the power, 78 watts. It's coming from the bulb. And then what's the L? Well, L is thickness. Do we have a thickness? We do. So something is trying to throw you off in this problem. You might think, because you see that word thick, oh, 1/6 inch. No. We're not just looking for the thermal conductivity of just something random. Notice that it says for the insulating material. That means that it is worthless to say what the glass box thickness is. We want to know what the insulation thickness is. That's 0.93 inches. Now, you may get problems like this where you're just not going to use something that's given, and you're not going to, in this whole problem, you're not going to use that. That is worthless to what we're trying to do. So, forget that. That's trying to throw you off. Now, what's A? That's the area. Well, this is just a dimensions. The area would be once you actually multiply that. That's 121 inches squared. We can put that for now. But there's something I'm going to mention later that is extremely important when we're converting to meters. So we'll leave it as that for now, but we're going to later have to change that. Then delta T, that is changing the temperature. Well, we remember last time in the lesson 2 we had to actually figure out what the change was ourselves, but this time we don't need to, because since it says higher, if it ever says higher or lower, that gives you a hint that it's already given. So we already know what that is. So we have everything now, and it seems like we're ready to just go ahead and plug in numbers. Well, first we're going to go back to the A. So remember, I said we needed to convert into meters. That's what we need. But you cannot convert 121 inches squared into meters. This will give you an incorrect answer. I hope you just absorbed what I just said. Once again, you cannot convert 121 inches into meters. It will give you a different answer. So first, what conversion factor can we use? So let's see. So 1 inch, I'll write it up here. 1 inch. I'll just do this so you can tell it's 1. It equals 0.0254 meters. So all we have to do is multiply our inches by that. So let's see what we get when we do 121 times that number up here. So I'm plugging that in. So we get approximately 3.07 meters. Now, if we solve this the correct way, we won't get this answer. We have to separately multiply 11 and 11 by that. What I mean by that is we have to first do 11 times 0.0254. We have to do that 2 times since 11 is the same both times. So that equals 0.2794, and that would be the same once again after we did that a second time, because it's 11 and 11. If these were different numbers, we would have to do it again. So then we multiplied that. Really, it's going to be that squared because you're multiplying it by itself. So I'll do that. 0.2794 times 0.2794. And then we get an answer of, by the way, if that was actually correct, it would be meters squared. We get 0.08 approximately meters squared. You can see that these two answers are completely different. You do not want to make the mistake of doing 11 times 11 and then multiplying it by the conversion factor. You have to do it separately. Notice we did 11 times 0.0254, then once again 11 times 0.0254. For both of those we got 0.2794. We multiplied that by itself twice, or basically squared it, and we got that. It's not the same as 3.07. It's far off from the same. So that's what we got. So now we have all of our numbers and we can plug it in. So first we can just do this, and I'll go ahead and put parentheses in the places where we'll put numbers. And I will just go back in blue and do that. So first we need to know the power, P, 78 watts. We don't need to put the units when we're solving, so I'll just put 78. Then L, we found out, oops, oh, about to make a mistake. That's incorrect because we have to do meters, so we have to multiply this 0.93 by 0.0254 as well, because that's still left in inches. Let's see what that is. 0.93 times 0.04, and we get approximately 0.02 meters, not squared this time. So then we can plug in 0.02, what we just got. Then we plug in for the area 0.08. Then for the delta T is 20, because it's 20 degrees Celsius. Now we can first solve what's in the denominator and numerator. So 78 times 0.02 is 1.56. Then 0.08 times 20 is 1.6. Then we divide, we do 1.56 divided by 1.6, and we get 0.975 as our answer. And you might be tempted to think that's incorrect because it's small, but usually thermal conductivity is a small number. Now we're not done. We have to have our units. Remember, the units are strange for this problem, and it's joules over S, which is seconds, times M, meters, times degrees Celsius. And our answer is this. That would be it for this video, so thanks for watching, and see the next video about how to calculate our value. Thank you.